Right now, let's look at the probability of events occurring when they cannot occur at the same time. It's kind of interesting. So here I have, these are called mutually exclusive events. If it's impossible for the two events to occur simultaneously in the same occurrence or in the same experiment, then A and B are mutually exclusive. And so I have up here this probability. Now this is an and probability, so I want to be a little careful there. It's not the goal of this to work with ands. We're supposed to be working with nots and ors, but still, the probability of them both occurring together is 0. An example, if H is the set of being dealt a heart, all right, so it's the different hearts that you could get dealt in a 52 card deck, and if D is the set of all diamonds you could be dealt, then it's impossible for a card to be both a heart and a diamond. So if I cut the deck and I showed you a card, the probability is exactly 0 that it's both a heart and a diamond on that same card occurring simultaneously, okay? So in this case, the probability that H and D occur is 0 on the same card. They can't. They're mutually exclusive, okay? But what's interesting is that when you think about one or the other, the probabilities add up, okay? So if you want to look at the probability of H or D, this one's a more interesting one, at least for what we're talking about. It's the probability that H occurs, or added to the probability that D occurs. So if I want the probability of getting a heart or a diamond, that's 1/4 plus 1/4, which is a half. Kind of makes sense because that's the red cards are half the deck and the black cards are half the deck, and this would be the total of red cards, right? So the probability is equal to the probability of H plus the probability of D. Again, this is true for mutually exclusive events. And so in this case, probability of getting a heart is 1/4, probability of getting a diamond is 1/4, and together they add up to 1/2. Okay, so the probability of one or the other is 1/2, right? If I pull a card up 1/2 the time, it's going to be either a heart or a diamond. 1/2 the time, it's going to be red. Okay, theoretically. Okay, and so this is true anytime you have mutually exclusive events. You simply add up their probabilities to get the probability of one or the other happening. Now we can also look at that in terms of the set theory or set notation, right? Because H and D are sets, and ors correspond to a union, whereas ands correspond to an intersection. And so we could say that the probability of H intersect D is equal to 0 for mutually exclusive events. And the probability of H union D is equal to the sum probability of H plus the probability of D for mutually exclusive events. Okay, so the or is a union, which gives you a sum. The and is an intersection, which in this case is 0.